One of the primary goals of this class is to determine how structure determines function. And so we want to be able to look at a set of reactions or reactants and determine not only what type of reaction they go through, but also what their mechanism will be, or what the mechanism will be for the reaction. So let's look at how to figure out if a reaction will proceed by an SN1 or SN2 mechanism. So one thing to recognize is that the reactions that we're looking at are controlled by kinetics. In other words, the fastest reaction is going to be the one that occurs. The reactions that we're looking at are all exothermic or exergonic, but they do have various rates. In other words, their activation energies are different. And so if you have variables that increase the rate of a reaction, then it's more likely that that reaction will occur. So one of the things that affects rates is the substitution at the alpha carbon. In other words, the substitution at the carbon that the leaving group is bonded to. And so remember with SN2 reactions that SN2 reactions are faster when you have less substitution. So methyl substrate has a lower activation energy and the reaction will be faster than primary than secondary. On the other hand, SN1 reactions are favored by more substituted substrates and by hyperconjugation and induction. Those additional R groups around the carbocation stabilize it. So the more substituted, it's the opposite trend as SN2, but the more substituted in SN1 electrophile is, the faster the reaction will be. Okay, so if you have a primary alkyl halide or other similar substrate, then the reaction will occur by SN2. If you have a tertiary substrate, then your reaction will occur by SN1. So the question then becomes, well, what about the secondary substrates, the ones in the middle? And that's really determined by the solvent. And so there are two types of solvents that are key here. Both of them are polar. One is polar aprotic. These are ones like DMSO shown here where it can't hydrogen bond. Compare that to polar protic, which has a proton that can be donated to a hydrogen bond. And so what happens is for the polar aprotic solvents, the nucleophiles don't have any stabilization from hydrogen bonding, but they do with polar protic solvents. And so what happens is that polar protic for an SN1 reaction stabilizes the polar intermediates in transition states. So it's stabilizing this part here, the charged part, and this is the polar protic. And what happens is they can just, all of that charged stuff in the middle there gets stabilized by the polar protic solvent. On the other hand, SN2 reactions are favored by polar aprotic solvents. And what they do is they act on the reactant and they actually make a nucleophile higher in energy, which destabilizes it and makes it more reactive. And so polar aprotic solvents, shown here, they leave that naked anion. So the anion is not as stable as it would be with a polar protic solvent, and it's ready to react. So that's what's shown up here. So overall, if you have a reaction, and you know it's a substitution reaction, if it has a primary substrate, it's SN2. If it has a tertiary substrate, it's SN1. And if it has a secondary substrate, look at the solvent. And if it's polar aprotic, it will be SN2. And if it's polar protic solvent, then it will be SN1.